Hello everyone, in this video we are going to see all about join strategies in Apache Spark with practical use cases. Before we get into the join strategies, let's see some of the key terminologies. First, let's see what is shuffle operation in Spark. Spark divides large dataset into small partitions that can be processed in parallel across multiple worker nodes. Shuffle is a process of redistributing and reorganizing the data across partitions in a distributed cluster. Since it involves transferring the data over the network, it is a costly operation. So, unless necessary, shuffle operations should be avoided. Now let's see what is a hash table. Hash table is a data structure used to effectively perform join operations between two or more datasets. Spark computes hash codes for the keys using a hash function and maps them to specific buckets in hash table. Hash tables are efficient for join operations because they allow quick lookups based on the hash codes. This reduces the need to scan through the entire dataset. Hash tables are created in memory and hence attempting to create hash tables for large dataset may lead to out of memory error. If you see this diagram, Spark compute hash codes for specific keys and maps them to specific buckets in the hash table. Now let's see the different join strategies in Apache Spark. There are 5 join strategy algorithms to choose from. The first one is broadcast hash join, shuffle hash join, shuffle sort merge join, broadcast nested loop join, and Cartesian product join. We will see the different join strategy algorithms and the practicals in the upcoming slides. Now let's see what is broadcast hash join. Broadcast hash join involves 2 phases. The first phase is broadcast phase. In the broadcast phase, small dataset is broadcasted to every executor that has the big dataset. In this diagram, we have one small dataset and a large dataset. And the large dataset is partitioned into 4 executors. In this case, the small dataset, which is represented in pink color, is broadcasted in all the executors. The next phase is the hash phase. The small dataset is hashed and bucketed in every executors and joined with the large dataset. Now let's see the practicals of broadcast hash join. I have my Spark session which is up and running, and I am creating 2 data frames df1 and df2 with one ID column. I have ID1 column for data frame 1 and ID2 column for data frame 2. I have created 2 data frames and I am going to join based on broadcast hash join. I am joining data frame 1 with data frame 2 using broadcast join. Data frame 2 is comparatively smaller than data frame 1. So I am broadcasting the data frame 2, which is the smallest data frame, into the executors which has the data frame 1. Now I am displaying the result. Here is the join condition. We have the result with values of ID column 1 matching to ID column 2. If you see the execution plan, we have broadcast hash join is used in the execution plan. I hope you got a fair idea of broadcast hash join. Now let's see what is shuffle hash join. Shuffle hash join involves 2 phases. The first phase is shuffle phase. As part of the shuffle phase, both datasets are shuffled. So the same keys from both sides ends up in the same partition. The next phase is hash join phase. In the hash join phase, the smaller side data is hashed, bucketed and joined with the bigger side in all the partitions. In this diagram, we have 2 datasets represented in green and in the orange color. Two datasets are shuffled into 4 different worker nodes. So in each worker node, the smaller side data is hashed, bucketed and joined with the bigger side in all the partitions. Shuffle hash join is different from broadcast hash join because the entire dataset is not broadcasted. Instead, both the datasets are shuffled and then the smaller side data is hashed, bucketed and joined with the bigger side data in all the partitions. Now let's see the practicals of shuffle hash join. Here is our Spark session which is up and running. I have taken the same data frame that we used in the previous exercise. Data frame 1 with one ID column and data frame 2 with one ID column. I am joining data frame 1 and data frame 2 with the ID column. And the join strategy which is used is shuffle hash join. In order to use the shuffle hash join, I am using the hint function and I am displaying the result. Here is the result. Now let's see the execution plan. Here is the execution plan. In the execution plan, we see that the shuffle hash join is used to join the two data frames. I hope you got a fair idea of shuffle hash join. Now let's see shuffle sort merge join strategy. Shuffle sort merge join involves 3 phases. The first phase is shuffle phase. In the shuffle phase, both the datasets are shuffled. The next phase is sort phase. In the sort phase, both partitioned datasets are sorted. The next phase is the merge phase. In the merge phase, both sides of the data are joined based on the join key. In this diagram, we have 4 worker nodes and we have 2 sets of data represented in green and in the orange color. As part of the shuffle phase, both datasets are shuffled in all the executors. Next, both the datasets are sorted in each worker node. And as part of the merge phase, both the datasets are joined based on the join key. I hope you got a fair idea of shuffle sort merge join. Now let's see the practicals. Here is our Spark session which is up and running. I have taken the same data frame that we used in the previous exercise. We have data frame 1 with one ID column and a data frame 2 with one ID column. I am performing shuffle sort merge join by joining based on the ID columns. In order to perform shuffle sort merge join, I am using the hint as merge. In the next step, I am displaying the result. Here is the join condition result. Now let's see the execution plan. If shuffle sort merge join is used in the join strategy, we see that shuffle sort merge join is used to join the 2 data frames. I hope you got a fair idea of shuffle sort merge join. Now let's see the next join strategy. Now let's see broadcast nested loop join strategy. Broadcast nested loop join strategy works by broadcasting one of the entire datasets and performing a nested loop to join the data. So every record from dataset 1 is joined with every record from dataset 2. In this diagram, we have 2 datasets represented in red and in the yellow color. The large dataset which is represented in red is partitioned into 2 sets. And the smaller dataset which is represented in yellow is broadcasted in both the partitions. So every record for the dataset represented in yellow is joined with every record for the dataset represented in red. I hope you got a fair idea of broadcast nested loop join. Now let's get into the practicals. Here is my Spark session which is up and running. I am using the same data frame that we used in the previous exercises. We have 2 data frames with one ID column. In the join condition, I am using the hint as broadcast. And in order to join the column, I am using a non-eq join. Here I am using a greater than or equal to in the join condition. If you specify broadcast as the hint and if you use non-eq join, Spark Optimizer always uses broadcast nested loop join strategy. Here is our result. And if you see the execution plan, we see clearly that broadcast nested loop join strategy is used. I hope you got a fair idea of broadcast nested loop join strategy. Now let's see the next join strategy, which is Cartesian product join strategy. Cartesian product join strategy works very similar to broadcast nested loop join strategy, except that the dataset is not broadcasted. The entire partition of the dataset is sent over to all the partitions for a nested loop join. In this diagram, we have two data frames and each data frame has two partitions. Each partition of data frame 2 is sent over to the worker nodes where we have the partition of data frame 1, and then a full cross join will be performed. I hope you got a fair idea of Cartesian product join. Now let's get into the practicals. We are using the same data frame that we used in our previous exercises. We have data frame 1 and data frame 2, and we are joining using Cartesian product join strategy. In order to use Cartesian product join strategy, I am using the hint as shuffle replicate NL, and I am using a non-EQ join which is greater than or equal to in order to join both the data frames. Here is the result. And if you see the execution plan, we see clearly that the Cartesian product join strategy is being used. I hope you got a fair idea of all the join strategies in Apache Spark, and I am sure that you learned something new today. If you do like this video, please consider to subscribe, and I will see you in another interesting video. Thank you.